1, where we take a deep dive into the world of crypto and teach you about the different aspects that make it tick. I'm your host, Jan Guillaume, and today we will be taking a look at proof of reserves, what it is, and why it's become such a pressing topic over the last 2 weeks. First off, Gate.io was the first mainstream crypto exchange to offer a proof of reserves audit in 2020. The company earned a patent in the process, and recently we announced and conducted our second audit, publishing the results early last week. With the current market turmoil and calls for all centralized exchanges to conduct proof of reserves of their own, Gate.io open sourced the method used to conduct its proof of reserves audit, so our peers have a proven method to conduct audits of their own. So, what are proof of reserves? A few weeks ago, we discussed how centralized exchanges work and how one aspect we discussed was how users deposit crypto into a dedicated wallet on an exchange and can thereby trade in different cryptocurrencies. These deposits still belong to the individual users, and exchanges act as custodians. Thus, these user deposits are held in reserve. Crypto exchanges are supposed to hold the crypto in dedicated cold and hot wallets until users choose to withdraw them. Proof of reserves is thus an audit that proves that the exchange holds all of the different assets deposited on the platform by its users. Because platforms can simply post a list of wallet addresses without actually holding all of the assets listed, Gate.io developed a unique verification method using a Merkle tree. Simply put, a Merkle tree, also known as a hash tree, is a cryptographic tree in which each leaf node is labeled with a cryptographic hash of a data block. Every non leaf node is labeled with a hash of the labels of its child node. Merkle trees allow efficient and secure verification of content in large data structures, such as databases with user balances. So, how do users verify their holdings using a Merkle tree? Well, the hashed user ID or UID and user balances are first exported from an exchange such as Gate.io's database. Each pair of the hashed UID and user balances will be hashed respectively and then concatenated to a form um, the underlying data block. For each data block, the same hash function will be applied to generate the leaf nodes of the Merkle tree. The resulting hash data are subsequently hashed together in pairs to create the parent nodes of each of the leaf nodes. The process continues until it results in pairs and a single hash known as the Merkle root. After the Merkle tree is successfully built, the leaf nodes will be exported into a plain text file, which will be published together with the Merkle root hash by the auditor. Since 2020, Gate.io has allowed users to manually verify their balances using this Merkle tree verification method on our 100% collateral page, which you will find at the bottom of the Gate.io homepage, or any other page for that matter if you visit Gate.io from a desktop computer. You might wonder why proof of reserves are important. So let's take a look at that. First of all, proof of reserves prove that a company does in fact hold all of the assets deposited by users. Secondly, it provides an added layer of trust that the platform doesn't use user deposits to make risky trades or bets on the market. Finally, it ensures that should a bank run occur, users will be able to withdraw all of their assets without any issues. And that pretty much sums up proof of reserves and how they work. That's the gist of it, and we hope you enjoyed the show. Be sure to check in every Monday, 12 p.m. UTC, as we host Crypto 101. Be sure to tune into the Gate update tomorrow, as well as the Web3 Wednesday show that we host every Wednesday. Both of these shows are also held at 12 p.m. UTC. That's all for today. Have a nice day. Thank you for